Alright, welcome to the final video of this section. Now, I'm really excited because you've made great progress so far, and it's a real honor for me to be able to support you on your journey. So let's take a look at the two challenges from earlier in this section. First, we'll find a way to brute force the second user from the Brute Force Me application, and we'll do this with both Burp Suite and FFUF. And then we'll look at the Analyze Me challenge so that we can forge a token and log in as Jeremy on the second application. Let's dive straight in. So here I have the Brute Force Me application up and running. And if we just come to login, and all I'm going to do is do Alex and Alex, and then double check that my proxy is on, which it is. And just click login and we get invalid username. All right, so I'll close this and then I'll come over to Burp Suite, proxy, HTTP history, and we can see the post request to /v1/verify. And if we have a look, we can see the username, which, apologies, yeah, it's still marked as email. When I update the labs, I'll get around to changing this. Originally, I was using email addresses, but then changed my mind for some reason. Forgot to update the attribute name, and we have the password as Alex, and we come back with invalid username. So let's just send this to intruder with Control-I, or you can right click and click send to intruder. And what we want to do is first clear the selections, and we just want to add one on the username. So to begin with, we want to try and find the relevant username. So here I'm going to think about what payload I want to use. So I know that there are some names in user share seclists, usernames, names, here we are. And we have a few different to choose from. So we have family names USA, female names, for names India, male names USA, and names.txt. And I think if we just check the length of this, just make sure it's not too long. 10,100, so that should be okay. I think we'll go with this names.txt. So load, and then we'll come back up to usernames, names, names.txt, and we'll hit start attack. And of course we're running locally, so it's not going to take too long to get through all of the 10,000 requests, and it's done. So first thing we want to check for is the status code. Everything is a 401, so unfortunately that's not going to give us a hint. And the next thing to check is the length, and as we can see, these two have a slightly different length. So it looks like admin, if we check the response, has invalid password, and Jeremy also has invalid password. Now notice the response length is very close, and actually if we take a little look at this, we can see that if we'd had a more consistent and better developer other than myself, the response lengths actually might have been the same, with the inconsistency here being the exclamation mark. Now if we couldn't find these, but we had an inkling that they might be in there, we go through a big list and we're like, no results really. We might want to do something, for example, is take the normal, something that comes back in the response of the usual response, come up to filter, paste this in here, and do a negative search. So we want to search for everything that doesn't have the string invalid username. And when we press that, we get admin and Jeremy. So if we were tricked and the content length was the same, then yeah, this is a way to find responses. So don't just rely on status codes and length. I think a lot of people, a lot of security practitioners get a little bit frustrated when brute forcing doesn't work out, but there is technique to brute forcing. It is a skill, and it's a skill that you really need to learn. So, don't get frustrated, hang in there and try and work methodically. So we have the user Jeremy, and I think we can just close this, discard that, and come back to the application and come Jeremy, hit login, and of course we get the invalid password. So we'll come back to Burp Suite, grab this. I could just update the intruder setup that we have already, but I'm just going to create a new one. I like to separate my workspaces so that if I need to go back, then I can go back and make changes. Add the payload field to this, and then think about the payloads. And again, we need to think about what password list we might want to use. So if we just ls user share seclists passwords, and there's quite a lot of lists here. So RockU is not too bad. Occasionally I use this Dark Web 2017, but more often than not, I've found it not to be that useful. The Zato one is not too bad. I think the best thing to do is think about what your target is, what you're trying to brute force, and then think about a combination of lists that might help. And to be honest, even with a little bit of Linux command line, not even that complicated, you could easily curate your own list that you can use in different situations. And that's probably going to be much more successful than just using a single list. So let's try the Zato top 10,000, I think, to begin with. We'll just load, come back up, passwords, and then 10,000 is a good place to start. Doesn't take too long, and we can see where we're at. And let's check for status codes, and unfortunately we didn't find it, and we'll just check the length for good measure as well. So we should get a login if we find the valid one. So in this case, I'm pretty confident that we didn't find the password based on the status code. So let's discard this, clear the list, load it up again, and we have a choice. Maybe we could go for a longer list. So we could go for this top 100,000, or we could go for a different list. So let's try the Dark Web top 10,000, because it's only going to take a few seconds to check. Still nothing, so let's discard this, clear. Let's step up to a bigger list. This one's going to take a little bit longer to run. All right, so we can take a quick look, and we got lucky. So on the 99,973rd request, we got a status 200. Interesting that the password is just a number. So let's actually have a quick look to see whether. So cat user share word lists RockU grep. It is in RockU, so we would have found it. Although RockU is 14 million and this was just 100,000, so we'd probably be here for the next hour if we were just using the RockU word list, which is why I generally avoid using RockU on online brute forcing unless I really have to use it. I mean, every situation is different, right? So we just click login and success. Here is your flag, and we get our flag and a pat on the back. So that's our brute force challenge done. And I can close this, and let's try and do the same thing again, but with FFUF. So I'll just clear this quickly. So we'll just come into our temp directory, and what I want to do is grab a request from burp. So let's grab the invalid one and work from that, because that's more realistic. So we're going to delete the old one that we had from the previous video, and then we're just going to vim rec.txt, pop this in, and then first of all we want to do the username. So I'm just going to put fuzz in here, save and close, clear, and then request rec, and then request proto http, and then our word list user share seclists usernames names.txt, and then we want to ignore 401s. So if we run this, we can see that we get tons and tons of 401 errors or 401 responses. So we can do this by doing FC 401, and we can also, if we want to filter out the size, I think it's FS, and we'd put in 30, for example. Since we're going for the username in this case, we actually want to get rid of the size of 30 and filter that out. That's correct, sorry, because the response is still going to be 401. And as you can see, we get admin and Jeremy. Now in the next attack, so let's update our payload. So we have Jeremy, and then the password is going to be fuzz. And then we're going to send the same one, but we're going to filter out 401s, and we're going to update the payload to passwords. And which list was it? It was the Zato, and it was a big one, so top 100,000, I think. And the nice thing about FFUF is that it's a little bit faster than Burp Suite, so should go a little bit quicker. Although, oh wow, a lot quicker. Yeah, this tool never fails to impress, and even though I've used it a lot, I'm always surprised by the speed. So it's found a status code 200 with this payload. And again, we can verify this by going to login, Jeremy, paste in the password, and we get our flags. So again, knowing the tools that we're going to use, knowing how to filter results and pass them correctly is going to be really, really important for your AppSec journey in general, but also with hacking APIs. All right, so here we are in API token analysis. So sudo docker compose up, and we'll come to our browser. I've already got Burp Suite running, and then just localhost 9000. And we just want to double check. Yeah, there's no cookies or anything that are going to mess with us. So if we recall, we remember from the previous video, we'll remember that the token is the username dash timestamp dash 3 random characters. And the timestamp would also pose an issue, but I think I already shared the hints that Jeremy logs in at the same time as the admin, so in this scenario. And so if we just log in, and I think the password is Ramirez, and yeah, we get successfully logged in, and we get welcome admin. So let's come back to here and go proxy, HTTP history, here's our post, and we get our token back. And we can see in the subsequent GET request, we have access equals this token. So let's take this token. I'm going to copy it, send it to the decoder. Decoder's base 64, and here we have our token. Now, how are we going to go about building a payload? So if we send this to the intruder, Control I, and then what we want to do is, sorry, that's the wrong one. If we send the GET request to the intruder, Control I, we actually need to be able to either have a list of tokens ready to go, or what we can do sometimes is just replace like individual values, for example. But then if we were to replace these individual values, we then need to base 64 encode the token. So there's a few different ways to solve this, but I think the easiest way is for us to just create a list of tokens that we can load in and attack the application with. So let's go ahead and do that with Python. And here scripting skills are obviously helpful. So if I just vim, let's call this tokens.py. And instead of vim, let's use mousepad as an alternative, and it might be a little bit easier to work with if I'm moving around and making adjustments. Now, we could use iter-tools, but I can't remember exactly how to use them. So instead of doing that, what we want to do is let's import base64. Oops. And we also want our character set. So this is going to be, oops, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, whoops, Q, R, S, U, V, W, X, Y, Z. I'm sure some people can type that a lot faster than I can. In fact, I probably should have just gone along the keyboard and done a keyboard walk, but you know, it's fine. Whatever works. And we also want the prefix to be this as well. And note that we don't need to brute force the timestamp because we know that Jeremy logs in the same time as admin. Although if we relog in as admin, it may reset that token. So just be aware of that. So yeah, instead of using iter-tools, I think we're just going to use for I in range, and we'll just do the length of the characters, and we're just going to nest some loops. I'm just going to use spaces for now because the tab inside of here is crazy. And then for j in range, and we'll just do the len again of characters. And if you don't want to watch me code this out, feel free to skip forward. I'm just basically going to make 3 loops, nested loops, so that we iterate through all of the permutations that can be generated. That's not a very good explanation. And actually, I'm going to create a list, so I'm just going to call perms equals, and then I'm just going to do bracket bracket. And here, we're going to do perms.append, and then we're just going to add cars I plus cars j plus cars k, and then we should be good. We need the prefix. So prefix plus this, and then at the end, once it's done that, we can do for perm in perms. Oh god, this keyboard is crazy. I changed my keyboard recently, unfortunately. Print perm. So let's just have a look, and then we need to base64 encode, and I can't remember how to do that off the top of my head. So I can't remember. So what we'll do actually is we'll use a burp suite option. I'm just going to leave it for now because we'll need it later on. But in the payloads here, you can see payload processing, and we can add a rule to encode our payload. So let's just use that for the time being, and we'll do this again in a second. So I just save this, and let's just close it, and then Python 3 tokens.py. Looks like that worked successfully. So let's do the same again and just output this to tokens.text, and then come back into burp suite and load in. We'll go to home, Kali, where were we? We were in temp, and then we have tokens.text, and here we have all of our tokens. And actually we made a mistake, or I say I made a mistake. This needs to be Jeremy, not admin, before I do that. So I'm just going to overwrite the tokens file, clear these, load it again. Whoops, I loaded the Python file. So tokens.text, and we have our Jeremy tokens. All right, and let's add our payload processing. So we want to encode, and then we want to base64 encode, and click OK, and let's start the attack. You can see we have about 35,000 items in our attack. What I want to look for is different length. All right, looks like I messed it up. So let me clear this quickly, reset the payload position, sorry about that, and start the attack again. So here, yeah, because I only set one payload position, we have much less requests, fewer requests. And then we can go and check the length. And we can see that, yeah, so sending a blank request obviously had a different length to an invalid token, but we can see request 3800 with this one here. So I'm just going to copy this. And if we actually look at the response, we can just see, welcome Jeremy, and says, hey, nice work, your flag is TCM, do. And we can verify this, so we can just update our access token here. Note the percentage 3D are just equal signs, so I think this should work because that's just URL encoding. So let's try. Yeah, we get welcome Jeremy, and we get our flag. So here, I think if you do see something like this, it's probably also going to work. Yeah, so we're all good. It's just a little bit of URL encoding quirks there. All right, so next up, we need to update our code quickly so that we have base64, and then we're going to pass it into FFUF. So mousepad tokens.py, and I realize actually this text is really small, so sorry about that if you were looking at that earlier. And then we've already imported base64, so what we can do is just do base64.encode, and I think it's base64.b64 encode, like this, and then we do .encode here, if I recall. Let's try it. Let's just run it and see. We get an error. My brackets are off. So let's try this again. All right, that looks like what we want, but it is a byte string, so I just did a quick Google, and yeah, I just need to add the decode, which I'd totally forgotten about. So if we have this here, and then we have encode.decode, wait, no. .decode here, we should be good to go. All right. So let's put this out to tokens.text, and then let's do FFUF again. So we want to do FFUF-request, and then we need our request.txt, so let's grab that. Oops. So rm rec.txt, vim rec.txt, insert this, and here we want to fuzz this request, and then fuf-request request.txt, and then request, proto http, and then -w, we want tokens.txt, and then we also, I'm going to run it for a second, and then we're going to look at the response length, and then we're going to filter out the response length. So if I just cancel this very quickly, And then the size here, we're just going to grab 384, and then we're just going to do -fc, sorry, 834, not 384. Oops, that didn't work. Oh, it's fs, not fc. There we go. And we got it here, so this looks like our token. So let's just check it. So we can echo -n, and then echo this to base64-t code. So fqd looks like the same one as last time, but what we'll do is we'll just remove this, refresh the page, we're not logged in, add a token, call it access, hit save, refresh the page, and we've solved this lab. Good job. So, sorry that might have been a little bit jittery along the way, but hopefully you got some insight into my troubleshooting process when I'm working on web applications. And that's it for this module. Authentication is not an easy topic and there's still a lot to learn, but I really hope that you've gotten a good foundation that you can continue to expand on. Great job, and I'll see you in the next section.